All right, guys. On the back side of this test, we're going to be solving logarithmic inequalities, and there are several possible answers, unlike an equation. You have to look at the inside of the logarithms, and you begin by saying that this x plus 2 has to be greater than 0. Why? Because if it were 0, you wouldn't be able to do log base 9 as 0. And if it were negative, you wouldn't be able to do it either. It's just something you cannot do. So when you set x plus 2 to be greater than 0 and solve it, you end up with a possible answer. X is greater than negative 2. That's a possible answer right there. That's one possible answer. The other possible answer is taking this 6 minus 3x and saying that that has to be greater than 0. And when you solve that, subtract 6, you end up with negative 3x is greater than negative 6. Divide by negative 3, and x has to be less than 2. Why did I flip it? Because I divided by a negative and it's an inequality. So I have another possible answer right here. There's a third possible answer. In this case, not in all of them, in this case there's a third possible answer. The first one was by setting this to be greater than 0 and solving, setting this to be greater than 0 and solving. That's the second one. And the third one's getting the whole thing and solving it as if it were an equation. So first of all, you don't want these log base 9s. So if you raise both sides of this inequality to become the power of base 9, you'll eliminate those log base 9s. So I'm going to take the entire left side and raise it to be the power of base 9. I'm going to take the entire right side, raise it to be the power of base 9. So 9 to the log base 9 eliminates. The x plus 2 comes down. The greater than symbol comes down. 9 to the log base 9 eliminates. And you have the 6 minus 3x that comes down. And there's your new inequality. So let's solve for x by getting rid of this minus 3x, by doing the opposite, plus 3x. What you do to one side, do to the other side. You will end up with 4x plus 2 is greater than 6. Subtract 2. We'll have 4x is greater than 4, which means that x will be what? X will be greater than 1 when you divide both sides by 4. So we have our three possible answers. That's the first thing you need to do. And then you got to go to a number line to see where the triple overlap piece is at. Now, if you got three possible answers, you want to look for that triple overlap. If you only have two possible answers, then you want that double overlap. So in this case, we have a number line, quick sketch. Let's begin with x is greater than negative 2. So here's negative 2 on the left side, greater than's to the right. Then we have x is less than 2, so we put 2 over here, less than's to the left. And then we also have x is greater than 1, so here's 1, greater than's to the right. So where's your triple overlap piece going to be at? Is it going to be between negative 2 and 1? No, it's going to be between 1 and 2, right? Okay. And sometimes you don't have a triple overlap piece, then you would say no solution. But in this case, yeah, the red continues to go this way, the blue is going this way, and the black is going that way. So obviously, right here you only have a blue, and this area is only blue. Right here we have red and blue. Right here you have red, blue, and black. And over here you only have red and black. So the triple overlap piece is only between 1 and 2. So your answer is simply putting x right in between, right there where that triple overlap piece. So your x is going to be right here, and put less than symbols, and there's your compound inequality. 1 is less than x is less than 2. So that's the answer for number 17. 1 is less than x is less than 2. That's your compound inequality right there. Okay, so let's jump to the next one, number 18. Now, over here, I had three possible answers. Why is that? Because I had something inside parentheses right here of this log base 9. I had something else inside parentheses inside this log base 9. And I solved the whole thing to get my third possible answer. Over here, how many possible answers do I have? 2, right? In here, I have an x. It says log base 81 of x. Now, we know that this guy cannot be 0 and it cannot be negative numbers. So my first possible answer will come by saying x has to be greater than 0. And of course you solve it, but then again it's already solved, so that's one possible answer. The other possible answer comes from solving the whole logarithmic inequality. So if I have log base 81 and I want to get rid of a log base 81, what do? Make this whole thing become the power of base 81. And what you do to one side, you do to the other side. Make that whole thing become this whole 0.75, make that whole thing become the power of base 81. That way, when you have log 81 to the log base 81, that eliminates. And what do we have left? We have a nice, beautiful x, bring down the inequality. And over here we have 81 to the power of 0.75. Now that will not eliminate, but if you do that on the calculator, you will get 27. Now, there is an actual explanation on how we get 27. You don't have to use the calculator. You could reason through it this way. 81 to the power of 3/4 instead of 0.75. 0.75 is really 3/4, which would imply they have a power over root. So you have the fourth root of 81. The fourth root of 81 is 3. But then you have the third power on that answer, 3. 3 to the third is 27. Use a calculator, you get that answer easily. Anyways, we have two answers right now. X is less than or equal to 27. And we also have x is greater than 0. Two possible answers. So since we have two possible answers, we need to find that overlap piece of those two answers. If there is no overlap, we say no solution. But we do have 0 right here. We have 27 over here. X is greater than 0, greater than to the right. And over here, x is less than or equal to 27. That'd be a solid dot going to the left. And there is an overlap piece. It is between the 0 and the 27. So your x would go right in the middle with the less than and with the less than. But because when we had the x compared to the 27, it was less than or equal to, right here, you're also going to have that or equal to. So here's your compound inequality answer for number 18. Moving on to number 19. 19. So let's begin with the possible answers by looking at the inside of those logarithms and saying that that inside cannot be negatives and it cannot be 0. Why can't they be negatives or 0? Because if you do it on a calculator, it'll say error. You cannot do common log of 0. You can't do common log of negative. You can't do any type of log, base anything of any negative number or 0. So that's why we have to go into the parentheses on these inequalities, not on equations, only on inequalities, and state that x minus 5 has to be greater than 0. And when you solve that, you're going to get x is greater than 5. That's one possible answer. The other one reads 2x, so that 2x has to be greater than 0. And when you divide by 2 and divide by 2, x has to be greater than 0 because 0 divided by 2 is still 0. That's another possible answer. Now the third and final possible answer is where you solve the whole inequality, logarithmic inequality, where you raise the whole entire left side to become the power of base 10, raise this whole entire right side to be the power of base 10, and we do that on purpose because 10 to the log base 10 eliminates, 10 to the log base 10 eliminates. We end up with x minus 5 is greater than 2x. And then we solve by moving x's to one side and getting x by itself on that one side of the inequality. So what we have here is 2x, take away 1x, that is x. We do have the answer right here. X is less than negative 5, but it's read backwards here. Negative 5 is greater than x. So let's flip it and make it look the way it's supposed to. X is less than negative 5. When you flip it, just make sure that if it was opening up to the negative 5, it still remains opening up to the negative 5. These are your three possible answers. Let's go to a number line to see where our triple overlap piece is. If there's three answers, you want the triple overlap. If there's only two answers, just the double overlap, right? So let's go to the negative 5. The x is less than negative 5. It's going to be over here. Less than is to the left. Okay, let's go to x is greater than 0. 0 is right here. Greater than is to the right. And let's go to x is greater than 5. Here's 5. Greater than is to the right as well. So where's the triple overlap piece?
5.
There is none. So what do we say? No solution. The answer to this guy is no solution. No. Right here we want a triple overlap piece because there's 3 possible answers. And as you can see, right here, it's on this side of -5, there's only one black line. Right between 0 and -5, there's nothing. And over here, there's only a blue line. Over here, there's a blue and red. But you want the triple overlap piece because of the 3 possible answers. So right here, you just say no solution. But here is the explanation for number 20. We want to let's begin by looking at the inside of those logarithms and saying, hey, this guy right here, it has to be greater than 0, or else it won't work. This guy over here, it has to be greater than 0 as well. 1 minus 3x has to be greater than 0. So we get our 2 possible answers by setting that as being greater than 0. Let's solve each of them. Minus 3, x is greater than -3. That's one possible answer. Over here, minus 1, we end up with -3x is greater than -1. Divide both sides by -3, and we get x is less than positive 1/3. It's another possible answer. And then we go back to the original logarithmic inequality and solve the whole thing by raising both sides to become the power of base 2. That way right here it eliminates, right here it eliminates, and we end up with x plus 3 is less than the 1 minus 3x. So we're going to find our third possible answer by solving this inequality. Let's move the x's to the left side. We're going to end up with 4x plus 3 is less than 1. And then we subtract 3. We'll end up with 4x is less than -2. When we divide by 4, we're going to end up with x is less than -1/2. You don't flip the inequality symbol. So you have those 3 possible answers. Let's go to a number line to see where our triple overlap piece is. So let's begin with this first one. X is greater than -3. Greater than's to the right. Let's go to the next one over here. X is less than -1/2. -1/2 is right here. Less than is to the left. Looks like it's overlapping right here so far, but we need that third one also represented. X is less than 1/3. So 1/3 is over here in the positives. Less than is to the left. So yes, the triple overlap piece will be between these two. Right over here there's nothing except the black one that goes that way. Right here there's the black and the blue right here. But right here you have the black, the red, and the blue. Right here's the triple overlap piece. Do we all understand that? I hope so. If you don't, I mean, you could extend it further and show that the black one goes that way forever, the red one goes this way forever, and the blue one also goes this way forever. So over here in this area, there's only blue and red. Right here you have blue, red, and black. Right here it's only black and blue. So the only triple overlap piece is right here between the -3 and the -1/2. So your answer will be an x right between that -3 and that -1/2 with less than symbols. There's your compound inequality for that answer, for that inequality. Your solution. What am I saying? Anyway, let's move on to the last one. On this last one, let's begin by stating what the inside of those logs cannot be, right? This guy cannot be negatives, it cannot be 0, so I'm going to write it as 8x plus 5 has to be greater than 0. Can't be 0, can't be negatives. And this guy over here has to be also be greater than 0 because it can't be 0, can't be negatives. So 6x minus 18 has to be greater than 0. Let's solve both of those. On the red one, when you subtract 5 on both sides, you'll have 8x on a not show all my work is greater than -5. Then my final step would be to divide both sides by 8, and you'll get x is greater than -5 divided by 8, -5/8. I hope everybody could follow along with that, even though I didn't show all my work. Now in this one, we have 6x minus 18 is greater than 0, so let's add 18 to both sides. Again, I'm not going to show my work, just I'm going to put 6x is greater than positive 18. Final step would be to divide both sides by 6, and you'll get x is greater than 3. I hope everybody sees that, even though I did not show my work. Now, my third possible answer will be going to the original entire logarithmic inequality and raising both sides to become powers of base 7. That way, 7 to the log base 7 eliminate, 7 to the log base 7 eliminate. We end up with 8x plus 5 is greater than 6x minus 18. And we want to get x by itself on one side, so if we subtract 6x, we'll end up with 2x plus 5 is greater than negative 18. So if we subtract 5 on both sides, we'll end up with 2x is greater than negative 23, which means that if we divide both sides by 2, the inequality will stay the same. It'll be x is greater than, for the sake of the number line, I'm going to write it as negative 11.5. Okay? X is greater than negative 11.5. So I need to see where my triple overlap piece is at. So I draw my number line, sketch my number line. I have the value of negative 11.5 way over here on the negatives. I have the positive 3 way over here on the positive side. And I have negative 5/8 in between the two. So let's go through and show the area. X is greater than negative 5/8. Greater than is to the right. X is greater than 3. Greater than 3 is to the right. And the last one, x is greater than negative 11 halves, or 11.5, I'm sorry, 11.5. Greater than is to the right as well. So is your triple overlap right here in between these two? Is it between these two? It's over here on this side, right? The blue exists right here, the red exists right here, and the black exists over here because they're all going in the same direction. So the triple overlap piece is only from the 3 on to the right. So your answer is technically only x is greater than 3, not the rest. So that's your only answer that you write on your number line, on your answer sheet. X is greater than 3. Because that's the only place that there's a triple overlap. Ladies and gentlemen, we're done with the third video. Whoops. If you need help on any other part of the test, the practice test, it's already uploaded on YouTube. It will be uploaded on Edmodo by the end of the day.